students, let's start with the chemistry, what we have studied in our previous lecture. Let's begin. See, in the previous lectures, what we have studied, we have actually completed the dual nature of light, in which we have studied the photoelectric effect and the wave nature and the particle nature as well. Okay. Besides this, we have just completed that there are some uncertainty principle known as Hessenberg uncertainty principle. I have just given a brief idea that along with the photoelectric effect, we also need to study our particular point that is known as Hessenberg uncertainty principle. Okay, after completing that, I have already described you a little bit that our Bohr's atomic model, due to some complications, due to some limitations, we have to avoid that particular case and we have to further move on to our new atomic model that is known as quantum mechanical model. That is quite new for you and that is totally important topic. Okay, so before starting the quantum mechanical model, let's begin with our topic that is known as Hessenberg uncertainty principle. All right, let's start. So what actually Hessenberg uncertainty principle wants to describe us, what it wants to convey us. Let's start. The uncertainty principle, as the name suggests, it tells us that there is always uncertainty for the small particles like electrons or the system that is in microscopic level. I think you are aware about the microscopic versus the macroscopic. What microscopic wants to say to us? Microscopic means the particles which are present at the small level. Okay, and if I'm talking about the macroscopic, it means the particles that are present at bigger level. They are visible to us. We can easily observe them. We can easily have some physical as well as chemical observation for them. But if I'm talking about microscopic level, that means these are so small, we need a microscope to check out them, to have some observation for them. Okay, so let's start. The Hessenberg uncertainty principle basically defines us that it's always impossible to determine, simultaneously the exact position as well as the momentum for an electron. Exact position and momentum for an electron. See, I have already told you that this concept is basically based on the concept that is on microscopic level. So microscopic level, we are dealing with the electrons. So एक electron के लिए it is always impossible to determine simultaneously the exact position as well as the exact momentum. For understanding us, he has also given us a mathematical simple observation, a mathematical formula that is delta x into delta px greater than equals to h over 4 pi. Let me explain this little bit. The x here represents position and the delta represents uncertainty. That means the change. X representing your position and delta x representing uncertainty in position, or if I talk in the mathematical language, I would describe it as the change in position. The delta here representing the change in position. I'm damn sure that in 10th class or even in 11th class, you're studying about the delta, the del concept that represents the small derivation. So the small deviation or the small change with a particular constant. Okay, same as it is if I'm talking about the delta px, the p here represents the momentum. And you know very well the momentum is also known as mass into velocity. So in short, we can change this mathematical formula to delta x into m delta v greater than equals to h over 4. Now the question arises, why we have taken m outside? You know very well, bache, the mass for an electron, proton, or neutron. Even if I'm talking about any kind of atom, the mass is always constant. You know that very well. I have been described this in your first chapter as well as in the second chapter when we have studied the discovery of electron, proton, and neutron. वहां पे we have concluded, वहां पे we have studied कि our जो mass है that is always fixed, that is always constant. So this is nothing. We have just a mathematical simple concept to understand this theoretical portion. Okay, that is delta x into m delta v greater than equals to h over 4 pi. What is h? That is our Planck's constant. You know that h जो है that is our Planck's constant. And the same as it is, 4 is a numerical quantity. The pi is also uncertain. The value of pi is 3.14 and so on, or 22/7. So in short, we can say this whole mathematical numerical value h over 4 pi is uncertain. I'm repeating it again. H over 4 pi is completely uncertain, and we have already put over here delta. That means this is also uncertain. So this Hessenberg uncertainty principle quite obviously is telling us that there is always uncertainty whenever we want to calculate our position as well as the velocity of electron, we can say, or the momentum of electron. All right, I'm again repeating. The uncertainty principle tells us it is always impossible to determine simultaneously the exact position and the momentum for an electron. And we have totally concluded, we have completely discussed that that's why due to uncertainty we have put h over 4 pi, because this is also uncertain, and we have put greater than equal. That means it should be equal or it should be greater than it. All right, so this is our mathematical derivation. Now this was all about Hessenberg uncertainty principle, but I need to convey you one more topic, one more point in this topic. He has told us that I am only valid for microscopic level. Hessenberg told us that this uncertainty principle is only valid for microscopic particle rather than macroscopic. Let me take an example, and you would see how it is only valid for microscopic, not for macroscopic. Okay, let's start. I just want to rub this for a small area so that we can deal with it. All right. So he has told us, let we have mass equals to milligram. Suppose what is a value of milligram? You know that very well. That is almost 10 raised to power minus 3 gram, or we can say 10 raised to power minus 6 kg. Okay. This value, even this value, which seems to be very small for you, even this value Hessenberg value into m delta v. I'm just using this equation. Delta x into delta v equals to, just for numerical values, just for numerical concept, h over 4 pi m. And what is h? The Planck's constant, 6.6 into 10 raised to power minus 34, 4 into 3.14, m I have taken in the milligram, that is 10 raised to power minus 6 gram. And when we solved this whole numerical value, what did we get? Yes, we get value almost equal to 10 raised to power minus 28. So even when we are having value at milligram level, the value of uncertainty comes around 10 raised to power minus 28, which is so small that it is for us totally insignificant. It is totally unbeneficial for us. It's of no use because it's so small that we cannot have further observation with this numerical one. All right. So Hessenberg told us, all right, I can't do this, I can't deal with this. I need only at microscopic level rather than the macroscopic level. Okay, this was all the concept which was described by Hessenberg's uncertainty principle. Okay, Ji. Now the point is what we have done. Is it significant for us? इतना कुछ हमने पढ़ लिया that there is uncertainty, there is a position, there is a deal, there is a significance, there is so much. But क्या इसका significance है हमारे लिए? जब उसने यही बोल दिया कि this is uncertain for us. So is it beneficial for us? It is totally beneficial for us. Hessenberg's uncertainty principle, when we did some numerical calculations, when we had some physical observation, what we have described, what we have derived, that Hessenberg uncertainty principle gives us the exact path, the exact trajectory, or we can say the exact orbit in which our electron is moving. So basically, it told us the position in which our electrons are moving in an orbit around the nucleus. Okay. And how these are moving and how the orbits are fixed. We will see as quantum. Okay. I hope यहाँ तक I have made all the sense. I have cleared the concept that why do we need it. Okay. One is known as quantum model. There are some numerical in your using phones and in which we need to locate, and I told you whenever we need to complete our Hessenberg uncertainty principle, we just need it microscopically. He has given us in the form of angstrom. And in the last 3-4 classes, I have told you angstrom, nanometer, picometer, that must be remembered to you, that must be in your brain, that must be completely cached in your memory. And angstrom defines us, I think you know that angstrom defines us 10 raised to power minus 10 meter. Okay. So हमें distance दे रखी है, that is in the form of angstrom, and that's it. We are required to calculate the uncertainty in the velocity. What would we do? We would put the same formula. We have m for a value is for an electron is equal to 9.1 into 10 raised to power minus 31. This is always fixed. Either I'm talking about electron or proton or neutron, the mass is always fixed. So now we have this our mass as well. We just need to calculate our delta V. Our formula would be little bit changed to delta X. And this would be changed as 10 raised to power minus 10. That is our delta X. M क्या है हमारा 9.1 into 10 raised to power minus 31. And we would solve this whole numerical quantity, and that would be equal to 5.79 into 10 raised to power 6 meter per second. Okay, ji. So in this case, I just wanted to say you that Hessenberg uncertainty principle as well as numerical based on it are very important. I'm damn sure that after seeing this whole concept, it's clear to you what actually Hessenberg uncertainty principle is and how can you deal with the numericals over. Okay, so now we need to move to our new topic that is known as quantum model. Okay, let's move. I hope you have remembered why we have rejected our Bohr's atomic model. है ध्यान? I hope जरूर ध्यान होगा आप लोगों को. In Bohr's atomic model, he has told us so many beautiful things. He has given us so many important terms, and we can say observation which were quite important for us, but there were some complications, there were some limitations. That was whenever we put any kind of field, it could be electric field, it could be magnetic field, जब भी हम किसी भी टाइप का फील्ड अप्लाई करते हैं, what would happen to our atomic model, what would happen to our hydrogen atom, क्या उसके लाइन स्पेक्ट्रा पे कोई इफेक्ट पड़ेगा, क्या उसके ऑर्बिट्स पे कोई इफेक्ट पड़ेगा. These were not explained by Bohr, and hence we have to reject that concept. Okay, so now we're going to move with our new topic, that is quantum's mechanical model. Okay, now what quantum's mechanical model is actually describing to us. See class, I always telling you that quantum's mechanical model is totally based on microscopic level, not on macroscope. Suppose I'm taking, let me change the marker. Suppose I'm taking 10 gram of gold, and I'm taking 10 raised to power minus 6 gram of gold, that is microgram. Whenever I'm having 10 gram gold in your hand, in my hand, there is some physical property, there is some observation of this gold in my hand that I'm taking, okay? But if I'm taking this particular quantity of gold in so small quantity, that is 10 raised to power minus 6, this property and this property, that is 10 gram gold and 10 raised to power minus 6 gram gold, these two are totally different. This has something different value, this has something different physical properties. And if I'm talking about 10 raised to power minus 6 gram gold, it has completely different properties. Okay, so in that case, what scientists have observed कि हमें एक नया concept चाहिए, we need a new model, we need a totally different branch of chemistry known as quantum chemistry, which only and only deals the particles at microscopic level. मेरी बात समझ में आ रही है? I'm talking that quantum chemistry is basically totally new branch of chemistry. It comes which deals with microscopic particles. बन रही है जी बात? At microscopic particles, due to different properties, we need a new concept. Abhi tak what were we studying? The wave nature, the particle nature, whatever we were studying, that was known as classical physics or classical chemistry. But abhi jo hum deal kar rahe hain, that is your modern chemistry. That is totally different from this. Okay, so let's start. Now, in the quantum mechanical model, what we have observed, what we have done, the quantum mechanical model has given us idea of atomic orbiter. He told us that yes, there is a nucleus and there are electrons moving around it, and these electrons are in fixed. So basically he wanted to give us the numerical as well as the physical significance about orbiter. मैं फिर से repeat कर रही हूँ that in quantum mechanical model wanted to give us the physical as well as the mathematical concept, the derivation of orbital. और इसीलिए we wanted a new topic, a new orbital known as quantum mechanics. Okay, so basically what he have done, he has given us so many theoretical values. उसने हमें इतनी लंबी चौड़ी derivations दी theoretical form में, और he has given us theories कि what is orbital, what it has physical significance, and so many values that we will discuss definitely. But the point is, for the layman, for the common people like me, like you, like other people who were surviving in that particular area, in that particular century, उनके लिए it was totally impossible to understand that all theoretical value, क्योंकि scientists they have some their own language to describe their topic. Okay, so solve this particular equation. What he have done, there come a scientist known as Schrödinger. एक scientist थे जिनका नाम था Schrödinger. Just to solve this particular problem, he gave us a mathematical derivation. He gave us some numerical values, some numerical constant in the form of equation h cap psi equals to E psi. What is this h cap? This is known as Hamiltonian constant. This is known as Hamiltonian constant. ये अब हम नहीं डिस्कस करेंगे. This is for the higher level. But this psi, this is known as psi, where P is silent. This is basically called as psi. Okay, P is constant and it would not be pronounced. Okay. So this psi has so much physical significance as well as numerical significance for us. So ये जो Schrödinger wave equation थी, it has given us the value of psi in the form of atomic orbital that we would study. That what are totally we can I can say what are the derivation, what are the important points we have studied in quantum mechanical model. Okay, so let's start. What are the physical significance, what are the important feature of quantum mechanical model of it? Okay, let's start. So he has given us basically 4 to 5 postulates, and each postulate told us a new concept, a new idea. First one, he told us the electrons in atom is quantized. First, उसने हमें बताया energy of an electron in an atom is quantized. What is quantized? What is quantized? Quantized means fixed. यानी इसे हम किसी ना किसी न्यूमेरिकल वैल्यू में ऑब्जर्व कर सकते हैं कि मान लीजिए कि मेरी जो इलेक्ट्रॉन है उसकी एनर्जी उसके ऑर्बिटल में जो प्रेजेंट है उसकी एनर्जी एक फिक्स्ड ऑर्बिटल में 5 ग्राम है, 10 ग्राम है, और अगर मैं एनर्जी में बात करूं तो 5 जूल है, 10 जूल है, 15 जूल. Okay, so firstly he told us that energy of an electron in an atom is quantized. That means it is fixed. बन रही है जी बात. Second point, he told us that the existence of quantized electron energy level is direct result of wave-like properties. Okay, तो second उसने हमें बताया कि जो energy है is only due to wave nature of these particles like electron. हमने observe किया था in our previous classes that we have 2 different ways to represent our energy. That is orbital, sorry, that was wave nature as well as particle nature. So उसने बोला कि जो energy है that is only due to wave nature of electrons rather than particle nature. Thirdly, he told us that he gave us the both exact position and the exact position as well as velocity of an electron is quite difficult. It's quite impossible to determine simultaneously. और ये हमने अभी study किया है in the Hessenberg uncertainty principle. So he told us that yes, Hessenberg uncertainty principle exists. Fourth point, he told us there is an atomic orbital which is wave function psi for an electron. So he told us an atomic orbital is wave function of psi. So basically he told us that only due to psi we can represent that there is known as an atomic orbital. Okay, I have already told you that this psi has much physical significance only and only in mathematical derivation, just to represent that yes, we have this atomic orbital, और इस atomic orbital का हमारे पास एक wave function है which is known as equal to psi. Okay जी. And lastly, we're going to move with our last point, that is known as psi square. Psi square told us that there is probability of finding an electron in an orbit around the atom. Let me briefly recapitulate this one, and then we would end the class with having some doubts of you, definitely, with some query session. Okay. So basically, quantum's mechanical model was based on microscopic level. I have told you why we need to study microscopic rather than macroscopic. I have taken example of 10 gram and 10 raised to power minus 6 gram. Okay. The first postulate given by quantum's mechanical model is the energy of an electron in an atom is always quantized. It is always fixed. It's always given into a numerical. Okay. Second, he told us that this energy is only due to wave nature of electron rather than the particle nature. He has given us that yes, there exists both wave nature as well as particle nature, but this energy is due to wave nature of our electron. Third, he told us that it is impossible to determine simultaneously the position as well as the velocity or the momentum of an electron simultaneously. Or we have studied this topic in Hessenberg uncertainty principle. So I have just written Hessenberg uncertainty principle. And the last 2 points were super important, as I have already told you, to just give us the numerical value, to just give us the numerical significance of an atomic orbital. We have taken a physical constant known as psi. So, उसने हमें बताया that our atomic orbital is basically a wave function of psi. And lastly, he told us that there has some physical significance. The value of psi, if I'm just going to square it, if I'm just going to double it, no double, sorry, going to square it, what would happen? The probability of finding an electron in an orbit around an atom can be calculated by this psi square. These all concepts were given by atomic orbital, and if I want to elaborate this last one topic, I can say that if our orbital is small, it is near the nucleus, it is small, what would happen? We can easily find the electron in that orbit. यानी मैं ये बोल सकती हूँ कि जितना ऑर्बिट का साइज स्मॉल होगा उतना जल्दी हम एक इलेक्ट्रॉन को फाइंड करने की प्रोबेबिलिटी हमारी ज्यादा होगी, उतनी जल्दी हम एक इलेक्ट्रॉन को उसमें फाइंड कर सकते हैं. ओके जी. So these all concepts were given by the quantum's mechanical model. This was super important, and I have told you a brief discussion that we have size, shape, as well as the physical significance of orbital. So in tomorrow's class, we will discuss the, we can say, quantum numbers based on the probability of finding an electron. कि वहाँ उसका orbital का shape क्या है, उसका size क्या है, उसके base पे we need some quantum numbers, which is very important. Don't ever miss the class of tomorrow, because in tomorrow's class we will see to calculate SPDF orbitals, जिसके बारे में आपने 10th class में थोड़ा बहुत पढ़ा होगा. We will discuss that in detail, and which is super important for chemistry. So don't miss tomorrow's class. Okay. So this was all about today's chemistry class. Now, if you have any kind of doubt or query, I'm open to that. Please ask me.